new people. Have you done anything in AS before? No?
So your voice is a little unclear.
I'm saying, have you done anything in AS before?
Yes, we're done with the first chapter in school.
Okay. Oh, well, you guys are pretty much. Okay, never mind.
So how about we start from the beginning?
Who says that? Who says that? Ramen?
No one.
Acha. Ramen. Well, do you want to start from the beginning then?
Sure, why not?
I don't mind. Okay.
Really?
Yeah, I don't really mind. It's okay. But by
What about your months of effort?
months of effort, you wasted it clearly, so don't know.
I didn't waste it. I'm just saying I won't mind a redo for everything.
Okay, redo. Well, we can do that today. I was
That was
basically
simple.
hoping that maybe I could create a new class, leave it as it is, because we really need to, finish this too.
Yeah.
Okay, I'll do that. I'll create a new class today. Don't worry. You can join that too then.
Okay.
Okay, because it wouldn't be fair with anybody else then. Okay.
Yeah, I was just joking.
So right now, basically we did work done to bring an object to the toppling point, right? Last time. And today we are going to start with the torque of a couple. Okay. The symbol for torque of a couple is this T called tau. So torque of a couple can be assumed to have an effect when number one, two forces have the same magnitude, two, they have opposite directions, and they must be parallel. They must uh, have parallel line of actions. That would be better. And they must act on the same body. Okay. Now, so suppose there is an object, right? Like this. What torque of a couple is that a force is acting upwards in this direction and downwards from this direction, and they have the same magnitude. Okay. So the first thing you should remember is that a torque of a couple, basically two forces of same magnitude in opposite direction. We've done that. Then the forces that you apply on a body must have a parallel line of action, and they must act on the same body, right? So basically, if this is the center, so a distance r from here and a distance r from here, they're acting, right? This is clearly, the center, something like that. Okay. And the total distance is basically this s. Now, what I want to tell you is that basically it's a torque of a couple, which means two forces, right? Now, so moment is force times. Okay. All right. So basically, moment that we have studied in O levels is force times the perpendicular distance, which is r, right? And now there are two forces. So basically, torque of a couple would be.
Sir, what am I doing today?
Sorry. SOL. Dua, how are you? Dua, are you there? So torque of a couple would be that this basically this force tries to turn it this way and this force tries to turn it this way. So this moment plus this moment and this moment added up, because they're basically in the same direction, right? It gives you basically 2f times r. Now please look at this very carefully. Here you might see that distance, this distance s is equal to 2r. How do I know? Because if you add r and r, basically it becomes 2r. And now in this equation, you can basically replace it. You can say, okay, torque of a couple. So you got f and you got 2r, so you can replace it with s. So it will be f times s. So what you're gonna do is, I'm just writing a note here so you guys understand what I'm saying. So the note is, torque of a couple would be one of the forces and the distance, which has to be of course perpendicular, between the two forces. All right. Any questions, please?
So basically, the forces should be opposite and parallel to each other.
Yes, that they should follow the four, the four, I would say, properties. If they don't, it would not be a couple. All right. And then to find it, you just need to multiply the magnitude of one force and the distance between both the forces. Understood?
Yes, sir.
Okay. So Hiba and Dua and Suhail and Khatija. Okay. How are you people? I want to hear you speak. Sohail ko to I know. For some reason, it's
Sir, we are good.
yeah. Dua, can you hear me? And Hiba? Okay.
Sir, so torque would be force multiplied by S.
Yeah. The distance between.
Yeah, but then why did you write 2FR?
Because if you look at it, you know what torque of a couple is. You see, just look at this force first. Oh no, this force first. Okay, Ramin? So you
Yes.
realize that basically, if this is the center, right? This is the center. So about this center, it is moving. It's this force has a perpendicular distance r, and it is moving it in the clockwise direction, right? And
Yes.
the other force, which is this one, it's also trying to turn it in clockwise direction, and the distance perpendicular to it is also r, right? If you turn
Yes.
it, you see, so the moment, what is the moment? Moment from O levels we know it is force times perpendicular distance, right? So what I've done is, when there is a couple, it means there is this force, the first one, added with the second one that produces the whole effect. Do you understand?
Yeah, but then shouldn't it be F into 2R?
It doesn't matter. When you add it, it will be 2FR, right?
Yeah.
And then what I did was I wrote, I separated F and I wrote 2R because this R and this R, when added together, is equal to the distance between two forces, right? So, which
Yeah,
is
okay.
this. So I replaced 2R with S, and then I got to know the torque of a couple would be when you use one of the forces and the distance perpendicular between the two forces, that would also give you the same answer. Is it clear? Yeah.
Yes, sir.
Sir, what is torque?
Torque is just moment. So yeah. Okay. All right. So for all the new people, which is Hiba and Dua and Suhail and Aman as well. Is it possible that I keep a class on Thursday, Friday, and Saturday at 7 p.m. Pakistan time? Is it okay for you people?
Sir, how about 7:20?
Why so?
Because from 7 to 7:20, it's time for prayer.
Prayer, Asar prayer.
No, Maghrib.
Where, where, where Maghrib? In Pakistan?
No, in Oman.
In Oman, how come at 7 p.m. you have, it's 6 p.m. in Oman?
Yeah, so when you have 7 p.m. in Pakistan, it would be 6 p.m. in Oman, so 6:15.
6:15 is Maghrib. Okay. 7:20 you say? Okay, 7:20 then. Fine. So
Yes, that would be okay. Yeah.
yeah. So I will ask the academy to inform you as well. Okay. Now, for all the people who are new can join. All right. Now, the thing is that when it's not a couple. Okay. So suppose you have so I'm going to show you three different conditions, right? Where you might see that it won't be acting as a couple. So if two forces are acting, they are parallel everything, but they are actually acting in the same direction, this would not be a couple. If one force is acting this way and the other force is not parallel, that cannot be couple. And also it could not be a couple if both forces are opposite, same size, but they do not have like different line of action. They do not have parallel line of actions. Is it clear, everybody? So this would not be couple. So if they ask you they will usually, usually ask you to identify what is a couple and what is not. So any figure or any sort of forces which do not basically conform to these four rules that are here, you just say they're not couple, and that could be these three conditions only. Is it clear, everybody? Okay.
Yes, sir.
All right. Now let's try and understand an example and see how a couple works, because you guys have done moments, so I believe that if you have done moments, it's not a very hard thing to do. So for example, say you got this figure shown. They say the center of the circle is S. That's the center C. And one of the forces acting right here is F1, and the other force, which is right here, is F2. And then the distance, this distance is 1 over 4r, and this distance from here to here is just r. Okay, and this is point C. Now, so the question says that force F1 and F2 are equal and opposite to each other. So it means they have the same magnitude and they're opposite, as you can see. Now they say, suggest if the two forces produce a torque of a couple. Alright, number one. And number two, they say, find torque of a couple in terms of F2 and R. Okay. So who can tell me if this is a torque of a couple or not?
Here it is.
Why is it a torque of a couple?
Sir, because the forces are opposite in direction, they are parallel to each other, and they're also acting on the same body.
Yes, exactly. So do not be afraid if they give you like a different distance. But the thing is, it follows all the rules that we have taught, that I've taught you. Number one, they have equal he has already said they're equal and opposite in magnitude. So two of our conditions are met, equal and opposite. Number two, they're basically parallel line of action and acting on the same body. So it means that this figure is experiencing a torque of a couple. Is it clear? Okay. Now if I say that this distance from this force to that force is S, right? So we know that the torque of a couple is basically one of the forces, which I could say F2, and because he wants us to find it in terms of F2, and that would be the distance between those forces S. So S itself basically is the sum of 1 upon 4R and R. So it is 1 upon 4R plus R. So the torque of a couple here would be 1 upon 4, and 1 is 5 over 4 R. So that would be 5 upon 4 F2 times R. Is it clear, everybody? Any questions, please let me know. Okay. All right. Hiba, can you hear me? Hiba?
Yes.
Okay. Do you understand, Hiba, anything? Khatija, how are you?
A very new chapter,
Yeah.
so I really don't.
Yeah, I know. It will be hard for you. Okay, it's okay for you to take class on 7:20 p.m.
Yeah,
Okay.
it's fine.
Khatija, how are you? Khatija, I'm sorry, we're really ahead in this section. I'll send you the new timings, okay? The academy will inform you.
Okay, sir.
But you can take today's class,
Okay.
alright, okay? Alright, then, now that we understand what exactly a torque of a couple looks like, so we can actually go towards another example. So this time they have given you a plank, and here from this point there is a force acting which is 40 newtons, and at this point there is another force acting that is also 40 newtons. The distance from this point to this point, this is 12 meters, and the distance from the start of the plank to this, they've given it as 4 meters. This angle is 50 degrees, so is this angle, it's also 50 degrees. Okay. Now, Ramin will tell us whether it's a torque of a couple or not. Yes, Ramin.
Yes, sir, it is.
It is a torque of a couple. That is true. And why is it a torque of a couple? Because it meets all the conditions that we've written. That they are two equal and opposite forces. They are parallel to each other, and they're also acting on the same body, right? Now, the issue with this question is that we do not have a perpendicular distance between them. Okay? So to do that, we have to find the components. Now, how do we find the components? The components can be from here. Those who have done scalar vectors at school can understand. One is the horizontal component, one is the vertical one. So this would be 40 sine of 50. You just need to find one of them because we know the distance between two forces would be 12, but we needed the perpendicular distance, so we found the perpendicular component. And now the torque of a couple can be written as one of the forces multiplied by the distance between them. So that's 12. So that's gonna be wait a second, where is my calculator? Okay, 40 sine 50 times 12. Oh my god, this calculator is gone slow. Okay, 367.7, which is approximately equal to 370 Newton meter would be the answer. Any questions, please let me know. When the meeting ends, you guys need to rejoin. Okay, the same link.
Sir, should I also rejoin or should I just join for the next class?
You guys can, the new people can actually join the next class. Okay, you will be informed to the academy, don't worry. Okay, now,
Okay.
now. Next thing you already know, so it's easy. Okay, so we just need to do some of the applications of both conditions of equilibrium. So what you need to understand is that when you look at, a seesaw, and we have done this question like 1,000 times, because it is the same in O levels. So two people are sitting, their forces, say 800 Newton, and this guy somewhere, close to this, 1200 Newtons. Here the distances are like 12, and here the distance is t, and of course there is going to be reaction force acting on the pivot as well. Now, so whenever you get a question like this, and they say, okay, find distance d and force r. Okay, so what you're going to do is, the step one is that you always draw directions. Now the directions are that, of course, the person on the right side is going to turn the whole thing about this pivot in clockwise direction, and this one is going to turn it this way in anti-clockwise direction, like this. Then for the first thing, you do sum of all moments about the pivot is equal to 0. Now this is the first condition of equilibrium. Basically it is we learned about clockwise equals to anti-clockwise thing, right? That's the principal moments. So in clockwise moment there is 1200 and the perpendicular distance is d, and anti-clockwise is 800 and the perpendicular distance is 12. Okay. Now what you're gonna do is you're gonna just find this, and this is going to be d equals to 800 divided by 12, and 1200 is basically 8 meters, as simple as that. When you have this, then you got to apply the second condition of equilibrium, that sum of all forces must be equal to 0. Now, so what you're going to do is you just write that upward forces must be equal to the downward forces, and that's how, their sum would come out to be 0. So the upward force is only R, and the downward forces are 800 plus 1200. So R is going to be 2000 newtons. Anybody who disagrees with this, please let me know. Okay. Is it clear? Javeria and Aman and Raman. Okay.
Yes, sir.
Okay, pretty good. Now, let's try and do a difficult question, but we'll only do when the meeting refreshes, okay? Just a second. Hamad. Hamad, why are you so late? Okay. Now, you guys have written this. Should I go on? Go forward from here? Now, so the next question, which basically is a different one, maybe you haven't done this before. So in this question it says find FA and FP. So let me show you how it is. So they've given you a blank, and this time there are two pivots. Pivot A and pivot B. There's one person right here. There's one person right here. And then they have their own forces, like this one has 1200 newtons. The plank has its own weight, which is 800 newton, and this person has 700. Okay. And from this point to this point, they have like individual, say, distances as well. So let's write that. So that's 2 meter, 2 meter, 2 meter, and 2 meter. What they want us is that there is a reaction force FP and there is a reaction force FA. So these two forces they want us to find. Okay, is it clear? Now, so whenever a two pivot system comes, right, what you're going to do is, step 1, pick your favorite pivot. Okay, so Aman, do you have a favorite pivot here? Please?
So the one in the scale,
Yeah.
800 N.
No, a pivot. You pick A or B. Pick one. What should we do? Should we pick A or
No,
C?
I'm both the same.
They are same, but I'm saying you pick one. Just pick one.
Oh, A.
Okay, A. So once you have picked the pivot that is your favorite, you can then move to step 2, which is apply principal moments on the picked pivot. You just need to ignore the other one, okay? And step 3 is that you apply equilibrium of forces then as well. Okay, so both condition of equilibrium. First of all, because Aman said it, because of her, we are going to do principle of moments about A. Right. So principal moments about A, we already know what that is. Sum of clockwise equals to sum of anti-clockwise. Now, when you pick a pivot, just forget the other one and see what is happening. So first of all, if you see 1200 about this pivot, you realize that it's trying to turn it clockwise. This force is also trying to turn it clockwise. This force is also trying to turn it clockwise. And FB is going to turn it anti-clockwise. Do you know why I ignored FA? Anybody can guess? I completely ignored FA because FA does not have a perpendicular distance from the pivot. Is it clear?
Yes.
Okay. So now check this out. So here, sum of clockwise. So I'm gonna do, the first one is 1200 and its perpendicular distance is 2, so I'm going to multiply that, plus the next one is 800. Its perpendicular distance is basically from the force till the pivot, that is 4, not 2, remember that. And then the third one is 700 and its perpendicular distance is 6. For the anti-clockwise one, which is FB, the perpendicular distance is 8. Now, when you do this, you're going to get FP, which is basically 1225 newtons. Is it clear, anybody? Everybody, any questions here? Please let me know. Okay. Now, then what you're going to do is, you're going to apply equilibrium of forces. And basically equilibrium of forces means that sum of all forces are 0. Basically what you're going to do is you just need to do the same thing. You're going to say upward forces are equal to the downward forces. Now, what are the upward forces? There is FA, there is FB, and there is downwards are 1200, 800, and 700. Thanks to the principal moments, we already got FB value. So from this, we can find FA easily. I'm just going to add the value of FB here. And this will get me the value of FA. You can just subtract it on the other side. So 1475 newtons. Okay. Even if you had picked pivot B, the results would be the same, all right? Just the directions would have changed. But it does not really matter which pivot you pick. Just pick whatever you like, okay? And that would give you the answer. Everybody understand this? Is this hard? Aman, Javeria, and Ramin is back. Aisha.
Yes, sir.
Okay. Hamad, are you here?
Yeah.
Okay, that's pretty cool then. Okay, all right. Now, Hamad, I'm putting you into a new group, okay? It's 7:20 p.m. Pakistan time, Thursday, Friday, Saturday. Okay?
सर
Yeah.
ओके
Because
लेकिन मेरी एक और क्लास होती है उसमें
कौन सी क्लास?
थर्सडे को
कौन सी क्लास?
आई थिंक मैथ्स की है
Maths with Sir Basim, right? Sorry, Sir Maz. Sir Maz is teaching maths, right, at that time? Okay. Do let me know, okay?
उनकी 8 बजे थी
So, ठीक है, it's fine. It's fine. 8 बजे is fine. Okay. वैसे भी class is around 40 minutes, okay? We'll start sharp at 7:20. So basically, I'll set up the recording first because I take 10 minutes to set up the recording always. So it's fine. Okay. Anyway, now we're gonna go forward and do the last type of question, and then you guys can actually go. So, example. Because I was thinking your school has an issue, right? Ends late, so you can actually be better in that group. And okay, so now let's check it out. Here you go. So suppose this point is O, this point is B, and there is a wire that basically is also supporting this plank right here, and this wire is right at A, and this is the end of the support is C. And well, the distances are given such that from here to here, here to here, and here to here. Okay. So this distance, oh, I needed to make one of the forces here as well. One of the forces is right here, which is the weight of the plank, 30 newtons. And okay, so this is 6 meters, this is 3 meters, this is 3 meters. Okay, and here there is a force T acting, and this height that you see from B to O, this is 10 meters. So they've given this right here. Okay, now this angle is theta, and they say find the tension T in the wire and angle theta. Oh, by the way, there is another force they've shown, which is R right here. Okay, now so R and T is not given. Now in such a question where they say, okay, one of the forces you need, okay, so the tip to solve this type of questions where there are two unknowns and one of them you need to find, always take the pivot where an unknown and unwanted force is given, which means that R is a force that we don't need. So what we can do is we can take O as a pivot so that it does not have a perpendicular distance, and if it does not have a perpendicular distance, that would mean that we do not have to worry about it at all, right? So keeping that in mind, I'm taking O as my pivot. Okay, now if I take O as a pivot and then I do sum of clockwise equals to sum of anti-clockwise, then what I'm going to get is I'm going to say, okay, so first force is 30, about O, this is going to turn it clockwise. T will have two components, one upwards, one this way. So this is a perpendicular component, so we really need T sine theta. We don't need T cos theta. The reason we ignore T cos theta is because T cos theta is parallel to the pivot line of action. It does not have a perpendicular distance, so just ignore it. So clockwise, and this is going to turn it anti-clockwise. Now about this pivot, I just want to tell you that here clockwise would be 30 times 6, the perpendicular distance, that's here. And for that one, it is going to be T sine theta times 3 plus 6 is 9. Okay. Now we get T sine theta as 30 times 6 over 9 is basically 20. Is it clear, everybody? Now still we don't have the values, so we can always find the values through a certain trigonometry. So if you look at this whole is a triangle and is a right angle triangle, and this distances are given. So in this triangle, if we use tan theta, so the perpendicular is 10 and the base is 9, because that's till the point here, it's 9. So from here, if I take theta equals to tan of inverse 10 upon 9, this will give me 48 degrees. And now I can put it back. So I can say, okay, theta is 48 degrees, so sine 48 would be equal to 20, and T then would be equal to 27 newtons. All right, is it clear, everybody? Any questions? So the reason I just wanted to, do this question with you was because I want to tell you, in any case you have unknown forces that you don't want to include in your, say, sprints of moments, just take the pivot where they're acting. That would remove them, and that would make your life easier. If we had taken any other pivot, we would have, we can take A, we can take C, then we'll be stuck, because then we don't know what R is, we don't know what T is, and both will be in the equations. Then we have to make multiple equations to solve them, and it's not a very, say, easy way to do it. Okay? All right. All right. So now this is basically the end of this chapter. We finished this, and thankfully I think we are done with all the forces. So I'm gonna check the worksheet that was remaining, force density wali, tomorrow, and then I'm gonna give you a worksheet for this one, and then probably we're just halfway the course. So if you guys also need to join the new class and you want to repeat the things before, you can join at 7:20. And it's not necessary for you people,